Hello and welcome. In this video, we'll be looking in depth into how to plot cubic graphs. Okay, so cubic graphs can have two forms. You can either have a negative cubic or a positive cubic term. What I mean is that the highest coefficient of x cubed is the most dominant part of this equation or this function here. Because as x increases, x cubed will be the highest. It will be the highest value, and this term here, the value of a, this constant a, will dominate what the actual will will be. For example, if x is 10, the 10 cube will be 1,000. So 0.2 times 1,000 here is, even though it might be a small value, is much more significant than, let's say, 20 here that would have been multiplied by 10. So value of C and B, as important as they are not as important as the highest coefficient here, which is sitting in front of x cubed. So it depends on the shape of the graph. It will highly depend on the value of a. Whether it's positive or negative will determine whether it will look like this graph or this graph. So why is it that this part of the graph is always pointing to the third quadrant? This is called the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Well, because when x is positive, when you cube it, the y value will be positive. So this part of the graph is where x is positive and y is positive. When x is negative, y will be negative as well. So negative x will give us a negative y. Alright, so that's why it ends up in this quadrant. Now this is where a value of a is positive. If value of a is negative, then when x is positive and a large value, well, when you cube, let's say minus 10, x is actually posit- uh, positive, but we multiplying it. Let's say this 10 cube, we are multiplying it by a negative value of a. So a here, let's say this a is, let's say a is minus 2. Minus 2 times 1,000 is going to be a negative 1,000. So that's why when x is positive, y will be negative. All right, that's why it ends up in this quadrant here. And when x is negative, y will be positive. That's why you end up in this quadrant here. All right, so these are the end points of the graph. What you notice is that this graph has maximum of three solutions or three intersection points with the x-axis. Now I'm saying maximum because in some cases it might have zero, it might have, well, it might have just one rather than zero. There is no way it will cross this line without crossing it. It will have at least one. Sometimes it might at, come and be tangent to it and then cross it. So in those cases, we call this like we only see two solutions, two distinct solutions, even though this solution will be repeated. So we'll look at the repeated roots in cubic curves uh, in more depth next. All right, so let's look at this example here. We've been given a polynomial in factorized form. So the fact that there are three brackets means that this is the highest power of x can be x power of 3 because we see there are three x's here. So, and this is very straightforward because we know that the x value, just like we solved quadratic equations, these solutions will tell us that where it will cross the x-axis. These are the x values where they cross the x-axis. Now, you see there is no sign in front of the x's, so this is a positive cubic. Value of a is positive because there are no constants that would make it negative. All right, so we are going to say that you just basically, when you ask to sketch this kind of a graph, you draw x and y. The left quadrant, it will have to come from this quadrant and go through to this quadrant. So these are the endpoints of the curve. So let's see. When x is 1 here, let's say x is 1, x is 2, so this is 1, x is 2, and x is negative 1, it will have to cross these lines. So it would have to come here, it would go down here, bounce back up through this point. We don't know what's the y-intercept, we're going to figure it out in a minute, but somehow it will go through this point like so. Now we also need to figure out what's the y-intercept. How do we do that? We say, what's the y value when x is 0? So y will be, when I substitute 0 here, here, and here, I end up with -2 times -1 times +1. So -2 times -1 gives +2. Y will be a +2. So this point here, y is 2. Alright, so this is simply a sketch of the cubic. Now it's not perfect, I know, but I'm just trying to show you that when x is positive in this quadrant, y is positive as well. And when x is negative here, y is also negative here. Alright, that's the nature of a cubic curve in a nutshell. So, and I showed you something like that. Alright, next example, we have 3 distinct roots again. This time this root is positive 2, this root, actually this is a negative x, so we have to watch out for that. Although this is telling us x is 1, so that's told me that my a value has to be negative because I have a negative sign in front of just one of the x's. All the other two x's are positive, so the one negative will remain as negative. If there were two negative x's, it would flip back to positive, but it's not. So these are the roots at the minute. So when I'm plotting this curve, first of all, when I put x and y axis there, next thing I know is that it will have to come from this quadrant, the second quadrant, and go away into the fourth quadrant. Somehow, the end of the graphs, I'll put the end of the graph there, the end lines. Then I'm going to just plot 2 and 1. Let's say 2 is here, 1 is here, and -1 is here. Alright, so when it's coming here, it will cross this line. There's no repeated route, so it won't bounce anywhere. It would go, I'd have to cross. Then I need to figure out what's the y-intercept. I know that the y-intercept has to be negative. So when I'm going to substitute x equals to 0 to figure out the y-intercept. I will have y equals to a -2 multiplied by +1 and another 1 here. So y would be simply just a -2. So this point here, y-intercept is -2. So yes, it could have been a bit neater, but in a nutshell, all you have to do is make sure your graph has, in general, a line like so. So this doesn't have to be a perfect drawing, as long as you indicate where the intercepts, x-intercept and y-intercepts are. That's good enough to get you full marks in the exam. Okay, so let's look at another example. This is still the same example, and I showed you by hand the graph will look like this. Alright, so in this case we have a repeated root at x minus 1. So this is telling us when I solve it, I will get at x equals to +1, I'll have repetition, repeated. right? So that means that it will bounce off this point on the x-axis. And the other root is x equals to -1. Now I check the coefficients here. Coefficients of x are all positive. So value of a, the coefficient of x cubed is positive. So when I'm plotting it, I draw the x and y axis and I say, okay, I'm going to have the end line here and here. In between, at x equals to +1 here, I will have a bounce effect. From this point, it's not going to cross it. The line of the graph is going to come, touch it, get tangent to it, but then it's going to bounce back up. And then it's going to have to cross at -1. Because if this is not a repeated route, the line will have to cross it. So we'll figure out the y-intercept in a second. So you put the graph, you draw the graph or you sketch it like so. Then to figure out this point, what do? We say, I'm going to substitute x equals to 0 into the equation. I will have -1 squared, right? Because there's nothing here. I take -1 and I square it. That will be a +1. And I'll times it by another 1 here, the second factor there, the third factor rather. So actually, the y-intercept is like 1 as well, +1. It makes sense for it because our graph is telling us to be like so. All right, so let's look at another example. I showed you this with hand drawing. All right, in this uh, question, we've been told to sketch this graph and consider this. One of the roots is obviously at x equals to 1, right? And when x is 0, we will get -1 times 2, which is a -2. So the y-intercept we figured out. I've just put them here because we've done this many times. So one of the roots is at -1, but we don't know the other two roots. Does it even have a root there? If you check the coefficients a, b, and c here, a is 1, b is 1, and c is 2. So when you put these into you check the discriminant, and the discriminant is negative, all right? So we actually don't have a root, and this is unfactorizable. We can't factorize this root. If it doesn't have its discriminant is negative, it cannot be crossing the x-axis. So what does this mean in terms of our graph? Our graph is still a cubic, and it's a positive cubic because the coefficient of x squared and x are both positive. So I write here a is positive. It will have to come somewhere here and somewhere there. But how is it that it will just have one root at 1? So that means that it will cross at this point where x equals to 1, and it may, we figured out the y-intercept is -2. It probably have this kind of shape. Now -2 here. It would have just crossed the x-axis at only one coordinate. It has only one root here because what I just explained with the discriminant there. So I'll show you the sketch. It will look something like so. Now I drew it as it went up and then down again. We don't know this effect. We don't know it, and you don't have to worry about it in the exam. Whether it goes up, it will be fine if you just drew a line and then just shifted it down. All right. So we'll look at this example. This is not from example from your book, but one of the questions, actually exam questions, also are like so, and it's important you understand what's happening here. All right, so we've been told to figure out the equation of the cubic given its roots from the graph. You can see here this root is of 1, and this has repeated to at x equals to -2. And I also point out this coordinate here that we're going to use in a minute. All right, so let's first of all write y equals to x plus this plus 1. When we put it inside the bracket, we're going to write a -1. And at x equals to -2, when we put it inside the bracket, it will be a +2 that will be squared. Now, when I expand this bracket here, I will have x squared plus 4x plus 4, and then I'm going to multiply it by x minus 1. Right? If you remember in chapter 1, I did tell you we're going to need to understand how to multiply these properly. So I wasn't just taking your time. So we'll have a -4 here. We'll have plus 4x here. We'll have x cubed here. We'll have plus 4x squared here. And we'll have a negative x squared here because of the -1. And 4 times -1 is -4x. So when I take them out of the bracket, I kind of make sure I write them like so. So I'm going to have x cubed here, then 4 minus 1 gives us a plus 3x cubed, and here these two actually cancel away, so I have no powers of 1. I had this was a power of 2, and I have a -4. Now, looking at this, if I say y equals to this, would you believe me? Why I'm doubting that this is our equation? All right, yes, c is 0. That's fine. We can have a 0c. But actually, I did point out this coordinate here. I said watch out for that. Because when x is 0, what's our y value? Y value is 8. All right? Why is it that this y-intercept is 8, but if I substitute x equals to 0 into this equation, I'm going to get a -4. All right. So what is it that I haven't done? All right. If you remember when I showed you a stretch factor with a with a quadratic, I did use the value of k in front of my equation. That's why I've left the gap here, because I knew I have to put a constant value of k and find out what it is. All right. So yes, this is what I'm going to do. Actually, it's going to be negative. When I substitute x into this equation, that's fine. That's what I'm going to do. I'm going to write negative 4k. All right. Negative 4k is equals to 8. Right. So figuring out what value of k is 8 divided by a -4 is a -2. Actually, my equation is y equals to -2 times all this lot. There is no mistake there. I've checked it. The bracket there is all fine. It's just the fact that I didn't have this value of -2, the coefficient of -2, inside the bracket. And you can tell, of course, and look at the end of the graph here. At the end of the graph is telling us that the value of a is negative. Right? And we didn't have a negative in front of x cubed, did we? That's why now we have a -2 that we need to multiply it into the function, all right? Into that bracket. So in the end, the final answer should be -2x cubed plus, no, I'm sorry, that's a -6. Let me, -6x squared plus 8. So now you see this plus 8 makes sense because that's when x is 0, that's what we get. So let me just wipe this off. This is all right. I write it again. Okay, so the takeaway is that make sure you use a constant at the after your multiplication. Yes, you do multiply the roots with each other, but make sure you use a constant. I don't mind what you call it, whether KL or any other term. This is a constant that you have to figure out, and this is a stretch factor, and probably it's like so. And this stretch factor, we look at it when we look at the graph transformations. All right, stretching graphs. It reflects as well. All right, so good luck practicing. Uh, these are some equations. I've provided this on your on the Word file that is attached. You're supposed to match these up with the correct equation. So pause the video, have a go at this exercise, and then I'll show you the answers. So the answers should be what's appearing here. All right. So good luck. And yeah, this question 6 here is where you will have to use the stretch factor. I'm giving you a heads up. So this is worth 4 marks because you do have to work out some extra things. All right. Good luck. I'll see you in the next video.